let's wait for another 1 to 2 minutes. Then we can kickstart today's class. As some of you trying to, ponders, do you need more time for your quiz too, in general? No, right? Plenty of times. What kind of format do you want to have your quiz to? Still MCQ? The answer will be yes. Okay. What else do you want? You're still happy with the MCQ. How about the complexity? Are you happy with this, or is it too difficult? For those of you, if you feel too difficult, raise your hands. I want to hear from you. A silence means they are okay with the complexity. And frankly speaking, right, most of the questions I set in the quiz are rather primitive if you talk about the needs in the industries. They are not tough at all. This is just general understanding. There are a few of them request you to think a little bit more in depth, but in general, they are rather primitive type of questions, right? The reason why it might be a bit tough for some of you perhaps have something to do with the background, right? It never comes from a data background, so you have some initial catch-up work that you need to do. Feel free to approach me if really you have difficulty to catch up in these modules, right? My role is to assist you, not just to make sure you learn, but also come to cover you up when you have difficulties. My time with you won't be forever. It's another 5 to 6 weeks time. Then we're going to say bye-bye to each other. Majority of you is not going to see me again for the rest of the 80 years or 90 years, assuming we can live that long. That's true, right? I've been teaching here for nearly 9 years. 80 to 90% of students were not going to see me in futures. 1 to 2% of them going to work together with me, right? Because full-time roles that they're interested in. In fact, I do have data engineering full-time roles. Vice presidents and senior vice president. If some of you, if you're keen, and if you feel you have passed experience hirings, right? If you're keen and if you feel that you want to try, let me know. But you gauge that before the day you come to talk to me, right? If you say, no, sir, I just fresh grads, maybe not so suitable for vice president roles. All right, any questions regarding the previous lectures? I will take it as no. You guys have to ask the questions because it will be difficult for me to gauge to what extent you guys will be able to digest the materials. So sometimes I assume you know nothing and I will keep on repeating the very basic stuff. Or sometimes I assume you guys know a lot of things. And I think I just came through critical and important concepts. It may not be fair for you guys. So raise your hands if you're really unsure. Remember, last a few lectures, yeah? We're going to have reserved 1 lecture for presentations, one more lecture for quiz, maybe half of the lecture for quiz. Only left with 4.5 lectures. And for majority, as I say, keep emphasize, for majority to us, that's the only 4.5 lectures we're going to see each other, exchange ideas. Okay? If not, let's proceed to the contents of today's lectures. We're going to spend all the time talk about streaming databases. You guys know what is streaming? People will say, streaming? Yes, sir, I know. I just watch YouTube videos. That's streaming, video streamings. You're not wrong. The information we're taking from YouTube is one type of streaming data. And the backends, there are streaming databases that allow us to be able to view the videos seamlessly. But before going to details, we need to understand there are 2 different approaches to move data. I still recall in lecture number 1, we'll talk about 6 different steps, right, on data engineering. Moving the data is one of the important steps. And there are 2 ways to do so. One is to move information by batches. The other one is to move information across through real times. What's the difference between the 2? Real time is very easy to understand, right? When there's a certain information I want to send across, I just send. I don't wait. How about move information across by batches? Any example you can think of? Anyone? Is there any times you're trying to purchase a ticket online? They can't inform you the status. They can only let you know by next day. Is there any times that we're trying to bid for a course, you will not be able to know the status of your bidding immediately? They can only let you know by next day. These are the analogies that when you move across informations or consume informations by batches. Because in the realities, moving information across by real time is very expensive. For example, if I want to know what is the total number of passengers arrive in Changi Airport in the month of February, do I need to send across all February's information second by second to your server or to your Excel file which you use to collect the data? You do not need to do so. You may as well wait end of February or early of March, the first day of March. You're trying to pull all the information in the month of February and you do your computations. And that's what's called move informations by batches or consume informations by batches. A lot of databases we discussed in the first few lectures are all known real-time bases. For example, if I need to produce the reports on daily basis for all the bank's transactions, how many transactions are there? What is the total transaction amount? Bank usually need to do that, right? To make sure they have enough liquidities. Also understand how much money they have made on that days. You do not need to compute that things on real-time basis. What the business stakeholders is keen to know is on end of the day, how much money we have made. You do not need to let him know or let her know first hour of the day, what is the volume, etc. It's not saying this information is not useful, but it's not critical. The decision will not be made on the hourly granularity. It will be made on daily basis. So there will be daily batch jobs. Each end of the day or midnight, people will send across that information. Then this information will be loaded into the Excel files or some dashboard for you to see the information. The other one is that you need to see the information in real time or near real times. Is there anything you can think of? What are the times that you need to see the information in real time or near real times? Any of you play stocks? If you need to buy shares, if you buy the shares based on the price you see yesterday, you'll be a big problem, right? Maybe you buy too expensively. Or maybe you put a price which is not realistic at all, right? You can't buy, you can't get any deals. So the real-time information for stock markets is critical. What other things you can think of? It does not need to be financial industries. Like GPS. If your GPS service providers or map service provider give you the road condition yesterday, are you going to rely on that map service provider? The answer will be no. So it got to be real time or near real time so that you can make your choice of the route. There are many more examples you can have, especially in financial markets. Real-time information sometimes very, very critical. Okay, so what's the difference between the batch databases, database is not the right word to use that. Batch data movement, data processing to stream data movements and data processing. The SQL databases, for example, when you put information into SQL databases, do you expect the user will read them immediately? The answer will be no. And when you insert data into SQL databases, typically you assume what information you need to put inside. So you know the end of the information, the end of the message. If I'm trying to put 10 records or the 86, 89 of the students' result into a score databases, I know there are only 86 students. I will insert those 86 students' records into databases. I know it will be done. But for streaming databases, you do not know. You do not know where is the end because the data keep on coming. It's like a flowing. That's why they also make a differentiations. For the batch data processing, the information they're trying to transmit or move across is bounded. Means that you know the starting point, you know the ending points. Deterministic. But for streaming data processing, it's unbounded. You know the starting point from the time I think you start the trigger, but you do not know the ending points. The market can keep on sending across the information to use. The upstream data sources can keep on give you the information, just like a sensor. Some of you wear the smartwatches, right? I do not know how frequently the sensor will generate the signal from your body situations. You keep on sending the information. There are probably no endings. That data sources is considered as unbounded. You do not know when you are finished. All right? Streaming can also be considered as a series of the events or flow of events. When I see the streaming of the data, right, it doesn't mean the data flow continuously every single second, non-stop at all, no, right? The streaming data is still a set of data, a collection of the data points. So you can still distinctively refer one data point or differentiate one data point from the other data point. It's just that they come so fast and they're unbounded. So that is the key characteristics why they are different from the batch data processing. So data point here, I think sometimes also be considered as an event. I mean, the example I put on screens, I think is the transactions. It can be other stuff as well, like a stock market information. But let's begin with the transaction first. Event ID. This can be any running index, right? Of course, it can be carry some special numbers as indications. This is identifier of this event. Timestamps. Typically, you do want to keep a time. And later on, we're going to share with you why time is important and the differences between the event time and processing times. Type of transactions, payment process, right? In fact, this one can be the status as well, right? Type can actually be, is this a pay now? Or is this, I think, a gyros? Is this, I think, a cross-border TT payments? Amount, currencies, right? You can add in a few more. Who is the one? Who is the payer? Who is the payee, etc., right? So this information can be sent across in a real-time streaming engines or streaming pipelines to get the information across. And we have multiple such events. One come after the others. It's like a streaming of the data points. Nothing very so special, right? People will say, sir, the streaming data processing must be very different from batch data processing. The data structures, the data contents must be very different. No. The underlying data and the contents may be the same as the one you're seeing in the batch data processing. It's just that the way the information has been consumed is very different. The way the information moves across is quite different. Just follow my thought processes. For any information movements to happen, you need to have a senders. You also need to have receivers. Right? Here, I think I see it as producers and receivers. In the streaming data processing, you also need to have both roles. And for you to have a streaming, that the sender or the producer need to send the information continuously to consumers. As simple as that. Nothing very fancy. As simple as that. How is this compared to the traditional databases like SQL databases we discussed earlier? The SQL databases, the databases can be considered as a receiver. The sender could be the upstreams. It could be somebody on and off generate the insert table statements, or it could be an upstreams production server that the customer initiate payment transactions. Those data points will be inserted into SQL Server as part of OLTP. Is this considered streaming? Streaming data processing? Think about that. Two important characteristics, I think, of streaming data processing. One, you need to have a series of the events. Two, those events have to be unbounded. Right? If you have clear ending points of those events, then this is will not be typically considered as a streaming. It could be considered as a batch processing. And all these things have to happen fast, real time or near real times. People may ask me, hey sir, can I use a SQL databases to mimic the similar characteristic I think you mentioned? In upstreams, I can use some programs, keep on inserting the data points, a series of data points / events into the SQL database. I make it happen fast. More than this, the SQL databases can consume a lot of data in very short period of time. It can do concurrency of insertion as well, or writing operations. It can happen fast. Then, in the downstreams, in order for me to receive this information, right, I just ask somebody, keep on query, select all, select star, right? In upstream, I keep on pumping information as fast as I can into SQL databases. In the downstreams, I keep on query, right? One is the upstream insertions. In the downstream, I keep on queries. I don't need to say every single second. I use a for loop, a while-true loop. Keep on queries, select stars from their databases. It's also near real time, right? What's wrong with that? I can get the information insert fast and consume fast. You got a sender, you got a receiver. Sender send very fast, receiver also receive the information very fast. Anything wrong? Not that wrong. Just about 1 week ago, I got an intern, smart graduates, I can't disclose which school I think is here, it's one of the top 3 schools here, share with me that how he used a Python script called, I think, a large language model to produce a summaries of the upstream emails. Emails, sometimes they come and go, right? You don't know when it will come, right? So he wants to download the email contents into the Pythons and use the large language model, curate the email contents and produce a summaries. Right? These emails, I think, are the service requests. Sometimes a customer write an email to complain. Sometimes the customer write an email to say, how do I set up this digital token, etc. Right? So that intern is actually trying to do that. You know what he do? He use a while-true loop. Keep on pulling the information from the mailbox. They don't care whether there's a new mail come over. Keep on pulling. And that way, he's trying to mimic, right? It's a real time. Well-true, literally well-true for loop. I thought that. Nothing wrong, frankly speaking, right? It's a sort of intern, right? But is there any better way to do that? Or what issues do you foresee if it's not a so-called intern project? When people constantly query the databases looking for incremental data changes so that they can mimic the real times. You guys think about that? I want to get some thoughts from you. Otherwise, I think if you can't understand the pinpoints and the drawback of things doing data pooling in this way, it will be very difficult for you guys to appreciate why people want to do streamings. Anyone want to volunteer? Nope, no problem. Li Tianyu. Yes. Mm. A DDoS attack. Wow. Okay. Okay. Mm. 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 Okay. 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 So Tianyu essentially is saying that I think by keeping query the databases by looking for new additional changes, it's like a DDoS attack, right? Means that I think it's like if one databases can handle only 200 concurrent queries, but in 1 second, if you are the one who occupy or take up 150 queries, then they only leave 50 query slots to all other users. Or if your computer is so fast, you take up all the 200 query capacity, right? No other people can access that database anymore. Every time other users trying to query their databases, they will be rejected because server see I'm overloaded. Well, you also get nothing because there's no data loaded. No new data has been inserted in the databases. The reason you're trying to keep on query is because you worry and you do not know when the new data point will arrive. Right? Hence, a better approach is that perhaps you only start to queries or pull information when the server tell you, I got a new data point. It's called event triggers, right? Then you go there, once you receive that signal, you go there, start to query that information. Yeah, so we'll talk about that. I think it's called message queue. Right before that, let's look into this. Assuming there's a way for the producer or sender send the information to consumers in a continuous and real-time ways. What are the potential issues you can think of? For example, I'm the producers, and you are the consumers or receivers. I send in the information to you. What are the potential issues you can think of? One, I sent too little. Most of the time you are idle, but that's okay, right? Because the problem is with me. I didn't send enough information. Two, I sent too much. You have the problems to receive all the information in time. Because every time when you receive the information, it will take some time as well, right? If I send too fast, like a machine guns, you can't handle that fast. There'll be some issues, right? Assuming I'm sending at 1 second 200 messages. Your processing capacity at your side, let's say you have a slightly lower end processors or PC, right? You're going to do 100 messages per second. When I send across, what happens to that 100 message? One, you simply drop. You process the first 100 message sent by me. The remaining 100 message, drop off. That's what other scenario you can think of? You see, you can apply pressure to producers. What pressures can produce to producers? You can notify the producers, I can't process anymore, you got to slow down. That's one way. 2, you mute the producers. I can't process anymore, hence you stop. Until I process all the previous information, no backlog, then you continue. You guys heard TCP connections? UDP connections? These are the connections, basically have that simple architectures. I send. Either you cannot digest, you drop off. Or you mute the producer, you can't send anymore. There's a drawback, right? How can you always guarantee that you don't enter into that situation? One way to do that, I have a super fast downstream receivers, which is always much faster than your producer, so I don't end up in that situation. But it might be difficult to guarantee, right? You may have a faster PC, but how can you control the network? Maybe you think you send very slow, but because in the producer side, the network speed is very slow. End up all the message, when they arrive to the consumer side, they come in one shot. It bursts the capacity of the receiver side. So there's a drawback, right? When you establish a direct linkage between the producers and receivers, then what do you do? Yes. Mm. Mm. Yeah, right. Yes, right. What do you do? Because the information flow, right? Once the information leaves the producer, you arrive at the consumer side. What he suggested to say, maybe you set a middle point here. And this middle point potentially can act as an inventory, a warehouse. Information you come to store in the warehouse first. And consumer, when you need to take the information, you come to warehouse, you take. This is just like a logistic providers. In the past, I think 10 years ago and maybe even before, every time we need to receive a parcel, you know what? I don't want to mention the company names, right? They have to make sure you have to be at home at the time to deliver the parcel. If you're not at home, they bring the parcel back. And you have to, afterwards, they leave your slip on your doorsteps. Please retrieve your parcel from the post office. And more often than not, I can tell you, 80% of times you will not be at home. I don't know why. They always choose the time you're not at home. So it's easier for them, right? They don't need to ask you sign this. Right? I'm joking. Yeah? That's exactly this. The producer is the postman. Consumer is you. When they come, they send to you, they expect you to be around. In the minutes you're not around, then there's no information sent across, right? They bring back the whole thing to post office. Yeah. What he suggested to say, now, when you deliver parcels, you don't need to make sure the consumer's at home. I go to, what is the things you call? A metal boxes downstairs, right? I put it there. What is that? Oh, collection points, right? The whole hive house or what, right? Yeah. They put it there. Then they send an SMS, notify you, your parcel is there, right? Anytime you are free, you go there to collect. Something along the lines. Okay, but of course, in the streaming data processing, it happened much, much faster, right? Not like the logistic case I mentioned, right? I don't think it will happen in real times. Let's go to the next page. I think the pooling just now already seen, right? This is the SQL databases I think I referred to you, right? So pause that for a short while first. I'm going to expand further. Why do we need to have a pooling or inventory house in between, right? You're going to soon appreciate the beauty of that. The pooling is the SQL databases version I see, right? Somebody in upstreams, it could be a sensors, it could be a banking, core banking system, keep on inserting data into SQL databases. Yeah. Then, as a consumer, we keep on writing the while true loop, query the databases. Any data? No, right? Any data? No, no. You can submit such queries 100 times in a second. Yeah. In Tianyu's way, there's a DOS attack. Right? Of course, it's a poor practice of programming, right? Nobody trying to attack the things. Yeah? Streaming is that when an event happens, when there's new data being created, the producer will tell you, sir, there's new data being produced. If you're keen, you come to collect the information. So most of the time, there will be no traffic between you and that so-called the data collection or the databases, right? So you don't occupy the traffic. The bandwidth will be reserved for other people who need to use for other purpose. So this is the difference between the two. Let's go to the next page, you will see. This is the so-called the pooling, the inventories. They have a nicer name. They call broker. You guys heard about Kafka before? Kafka is one of the message queue, or you can see message brokers or message inventories or message pooling systems. They will act as a bridge between producers and consumers. So every time when the producer produces some things, they put the message into this message queue or message brokers. The information was stored there. And consumer will be notified by the broker here. Like an event. Mr. Consumer, I have a new message. Then consumer will start to consume. And also, for a good portion of the message queue systems or message brokers, every time when consumer consume the information, they will send back acknowledgements to the brokers to say, Mr. Brokers, I already consumed the information. Now you may delete this information. That's why it's called streaming. Otherwise, it becomes a database. After you consume, the information will be deleted from the message brokers. And the whole thing carries on. Simple, right? Then people will say, how much information should I store in the message brokers? It depends on your applications. Where should I store this information? Should I store in RAMs or should I store in hard disk? It depends on your applications. Can you think of some things that you guys have been using follow this type of messaging flows? APIs depends. For example, like the Yahoo Finance, right? In your lectures, is it a streaming data processing? Does it have a message brokers, a message queue in between? Does the information happens in real times? Do you consume this information when there's an event been triggered? Think on that, huh? I think all of you go through that code at the Yahoo Finance, right? When you pull the information, what type of information do you put there? Stock price information. Do you put the information real times? You pull the historical information. At what granularities? Daily basis. You have the high, low, open, and close. So is that streaming? What other API services do you think potentially could be streaming? When you have a real-time transactions, you're seeing that when their transaction has been completed, you get notifications, and the chart, I think, your apps, I think, essentially will be reflected. That sounds to be real times or streaming data processing. But more often than not, I think, assuming your information will not get updated the seconds when there's a transaction. Likely every 5 minutes, every 10 minutes. So it's actually still be processed by micro batches. Sounds like a streaming, but it's probably still micro batches, right? So they aggregate this information. It doesn't mean you can't do it. They aggregate the information every 5 minutes, every 10 minutes, because they know as a user, you don't really so concerned to get the immediate updates every single second. Any other you can think of? How about the LinkedIn? How about Twitter? How about Facebook? This could be considered as a quiz 2 questions, I think. You cannot say you do not know Twitter, Facebook, right? Sorry, Twitter, you guys may not use that. Do you guys use Twitter? No? Donald Trump ruled United States by using Twitter. Facebook? Also no. Oh, I must be an old monsters, yeah. Instagrams. Now it's the most in thing, right? Instagrams. Okay. Maybe I think I'll try to install Instagrams this week. What else besides Instagrams? Little Red Book, do you guys use? Chinese called Xiaohongshu, do you use that? But do you get real-time updates when people press a like? Near real times. LinkedIn, I know, right? I think it doesn't give you real times. Probably every 5 minutes, every 10 minutes, they're trying to sync the data. And anyway, you consume those data I think passively, right? You're not trying to subscribe to LinkedIn, keep on pulling information from there, right? So this might be some nice thing for you to think, and this could really be appear in, of course, in your quiz in a slightly different forms, Okay? I think this one I think we'll cover as well. Direct message between producer and consumers and the broker base. Direct, your TCP, UDP, you send the information directly. If the consumer cannot digest, there are only a few outcomes that will happen, right? They drop the message. Then end up in the downstreams, you receive incomplete information. 2, to apply pressures to the upstreams. Don't send it to me anymore, I can't receive. So the producer will be muted. Or potentially, they negotiate, they send much slower. So for critical applications, you may not want to use this, because you can't guarantee every single information sent across the network will be accounted for. You may want to try this. This will also help you to remove the dependency, or they have a nice word called decouplings, between the producers and consumers. The same logistic examples, right? When the postman sends the item to you, you don't need to make sure you're available. They just send this to the collection points. Comes to streaming data processing. There are multiple ways. I mean, this one I try not to go very, very in depth because I think this is, I think, the first time we talk about this, right? Of course, if you later on to say, hey, sir, this is okay, right? Of course, we can talk a bit more details. Let me write something down. The simple example I give it to you is one producer and one consumer. There's a broker in between. Have you considered or have you think of their scenarios? What if there are multiple consumers in the downstreams? When they send stock price updates to all the downstream people who need to consume the information. The producer only produces that message one time, but the consumer may have many. So this is called fan out. The same message will be sending to multiple different users. So in this case, right, I mean, if consumer one read the message from the brokers and send acknowledgements, I already read that. The broker must be smart enough to say, just because one user acknowledged that doesn't mean I can delete the message, right? This is different from the one-to-one scenarios. The other one is that in my downstreams, I may not need people to receive exactly the same message, right? I use this broker as a conduit, as a channel. I can produce message 1, 2, 3, 4, 5, 6. The consumer, when they when they've been notified by the brokers, there are new message generated in the systems. I go inside to find the message that means for me. It can be by sequence, it can be by certain type of IDs, etc. So for those of you who are working in projects, this could be a nice idea. Decentralized, not say decentralized, right? This sounds like a streaming data processing. But we could also help you to coordinating your own computational resources in a very decentralized ways. For example, you have multiple different tasks. You want to send to different processors to process that subtask. When you write the code, when you do that sequentially, you run one by another, right? But if you try to use this as your task dissemination platforms, task one could be your message one, be picked up by consumer one. In this case, it can be your worker one. Task two can be done by worker two. Task three can be done worker three. It's a nice way to have decentralized computing. And of course, the coordination will all be asynchronously, right? So once worker one pick up the message from the brokers, he will do his own work. Similarly, worker two and worker three, etc. And when worker one have not received the task or the message compatible to his, he just keep on listening. Listening means that they wait for the brokers to trigger him. They do not have to keep on queries. So this could be one of the nice ideas for you to consider. Very different from typical Python job we do, right? Write a main function, process things from the top to bottoms, like the one I think we share with you, the stock examples. There's something new. I know most of you probably have never coded in this ways. That's also the reason I think I add in some examples, right, in the appendix. I also attached the so-called the pseudocode scripts for you guys to, if you really want to adopt, you can use that as well. I can share with you, I think as a year of 2009, this is like 70 years ago. When I worked as a consultant, I think providing consulting services to one of the maritime logistics centers, actually it's the port terminals thing here, right? So back then we need to find a proper way to allocate resources to all the key cranes. You guys know what is key cranes? Key crane is the big cranes near the coastal side. Whenever key crane is this. Big cranes. Whenever there's a big ship carrying thousands of containers, when the berthings means that they park themselves near the coastlines, right? The key crane, which is super big, will going to pick up the containers, mount the container in the prime mover. It's a fancy name for truck, a big truck, right? Then the truck will going around, right? So back then we implement, I think, a marking mechanism helping them to allocate the trucks to various different key cranes who have different type of loads, right? So we decided to use the marking mechanisms. Yeah, each key cranes will serve the role of bidder. Then the yard masters means that somebody who owns the entire port terminals will be like something like a resource owners, right? They will take the role of the auctioneers, right? They own all the resources. So the yard cranes serve as agents. They bid the price. They bid a price for all the prime movers, the trucks. The auctioneer, which is the yard owner who own all the resources, the prime movers, well, based on the price, based on the price, based on the bid in each of the slots, right? They check between the demand and supply, adjust the price accordingly. So back then, we were using something similar to this. The stuff I think we're using is called qubit. This is just an anecdote, right? How people use that in the practice. The qubit essentially serves as a conduit between the bidders and the auctioneers. Auctioneer, every time when they check the demands and supplies, they need to adjust the price, right? If all the yard cranes trying to bid the trucks in 9 a.m. to 10 a.m. the slots, the demand is way more than supplies, they need to jack up the price. So that some of the yard cranes, some of the key cranes were trying to utilize the resources in other slots because they're too expensive, right? Assuming it doesn't have a big agenda to fulfill, right? So you're trying to minimize the cost. So the information in this case, it will be a fan out. The auctioneer, based on the demand and supplies, adjusts the resources price for each of the time slots and publish this information to all the bidders. The bidder, once they receive the information, they start to do computations. The computation, I think it can be OR problems, can be a scheduling problem done by heuristic approach, right? After computation being done, they submit the information back. So back then, we're actually using this qubit final approach. But we're not going in very depth to say, what if there's an information lost in between? Means that, what if some of the bidders, somehow they take very long time to receive the information? What if some of the bidders, due to various problems, suddenly dies? Means that the computer being shut down. Then how? So we didn't consider all these IT architectures, I think, how to deal with the exceptions, right? Because most of the times, it's working okay. And this is basically for those decision makers, right? Running this to find a proper schedules for all the trucks, the prime movers. So I think we didn't really consider very thoroughly from the software engineering point of view, right? But they get it done, right? And this is how people use this for computations. So it's not just the so-called Facebook things or Twitter things, right? It can be used in many other ways for you to organize the resources. Yeah, all those computations are not near real time, but not real time, because for each of the bidders or the consumers, it takes quite a while. Easily can take 1 to 2 hours to do the computations. But this is how people use the use the streaming concept to pass the message around. Anyway, let's go. I think this example I give it to you, right? When the brokers send updates to all the consumers, I got a new message, new informations. Consumer or the downstreams will take that message. They can just simply do a rate, or if you have complicated process, the consumer can be a worker as well, right? They process the informations, maybe even store somewhere, right? Then they send the acknowledgements to the brokers. I already received the information. Now you're safe to delete that message. In the scenario, for example, right, the step number 3, the acknowledgement sending back somehow get lost or get much delays because of network issues or because of other issues. Smart brokers typically will have some sort of threshold, right? And by what times, right, after they know the consumer start to consume the information, but after 5 minutes or 5 seconds, it never receives an acknowledgement, then they know something get lost. And you may potentially consider to send this information again to the consumer. Trigger, there's new notifications, new message have arrived, you please come to take. So that from the producer side, you trying to minimize the chances the information get lost. But that also create problems in the downstreams, in the consumer side. If that guy already consume and process the information, he just somehow, and he also attempt to send the acknowledgement back to the producer. But the issue is that he doesn't know. The producer didn't receive the acknowledgement. End up producer trying to redeliver the same message to him again. He may consume the same message 2 times. So in the downstreams, I think we also need to be careful, right? That's why I think in the events data creations, you can see, right? I can use these examples. Sometimes the important are you have some sort of identifiers, right? So in the downstream, when people notice they receive the same message 1 time, 2 times, 3 times, they can do some deduplications. And all this happen very, very fast. Okay? Before I talk about partition locks, in the example I gave it to you just now, all assumes after the whiles the message in the streaming data processing system will be lost, right? Why I see it's lost? Anybody can explain why I see after a while the message in the brokers or in the streaming system will be lost? Analogy for you. I'm pretty sure you guys still watch YouTube, right? I'm not that, like old masters. When you watch YouTube movies, after you finish watching, would there be any data being stored in your computers? Don't have, right? This is different from you download a movie online than watch on your local disk. After you finish watching the movie files are still on your desktop, your computers. Streaming different, right? There will only be some intermediate files being stored in part of your hard disk. After you finish watching the movie, that intermediate files will be deleted automatically without your awareness. So come back to the broker streaming system I mentioned. Is it mine? No? My phone is not with me. Yeah. Why? So why I say after a while the message in the brokers will all be gone. Why? Because it's by design. What designs will make the information gone? Anyone? Let me ask you. Li Wen. Xin Li Wen. Not around? Oh, Elaine's not around as well. She emailed me. Yifei. Today, I think we have minimally 80% occupancy, right? So many people here. Yifei, are you around? 2 people in a row. Rui Yao. Rui Yao. If you're around, just voice out, right? I can see, sir, I do not know. It's better than I mark you as an absence. Also not around. Thank you. Yeah. Do you know the answers? Or what question am I asking? It's okay. It's okay. Yeah. I think I better share with you. Yeah. Why I'm saying that in the broker streaming data processing system, after a while, the information inside it will be gone. It's because there's a clear steps. After the downstream consumer consume the information, you delete them. If you don't delete, this will become what? This will become a databases. The information keep on coming and stored there. Right? It's the same analogy lah. When you watch the YouTube videos after finish, there's no interim files or movie files being created and stored in your laptops. I mean, you guys are very lucky. So during my days, year 2000 in US, if I need to watch your movies, besides going to cinema, you know how am I going to do that? Huh? I'm probably not supposed to say that, right? Yeah. Yeah. I have to ask my friends, share the folders in US, local labs, so I can access their copy and paste. And it could take 10 to 15 minutes to copy. That's considered very fast. Huh? If somebody need to download online, I can tell you it could be easy half a day if you want to do this time. Just for a movie file, 800 megabytes. The format we're using is RMVBs. You don't even know what format is that, right? WMVs. Nowadays, you still have MOV. Yeah? Windows Media Players, right? Okay, yeah. Nowadays, I think you guys are very lucky. I don't think you need to go around to download the movies, right? It's probably not very right to do so as well, right? You probably watch from YouTube. You don't need to bother about this. So, if I really want, because I worry after a short while that all the information will be lost. And the information sent across may be something important to me. For example, like stock price. I really want to keep a copy of these information. What should I do? There are more than one way to do so. From consumer point of view, and from broker point of view. From consumer point of view, if I'm the one who read the stock information, right? So every time there's a new price changes, the order book has been updated. Means that there are new bidders and new sellers that are there in the stock, right? I consume, yes, but in the same time, I want to sift these informations. You actually can. When you read that information, you make a local copies. And you can even insert that data points into the predefined databases you have in SQL databases, columnar databases. Then the message brokers or the message queue will delete the message in the broker, in the middle points. You keep a local copy. That's one way. I've done that. And many people have done that as well online. You guys, again, by no means to see that you don't respect the copyrights. There are many tools online that they're trying to help you to rip YouTube videos into local files. I think they are using something similar. Read the information somewhere, make a local copies, and give you the final output. So that's from consumer point of view. From the message broker point of view, can they keep the information permanently? In the standard setup, of course no, because by protocol you need to delete. But there's another type of message brokers. They are log-based. And the reason why they want to keep this information is because for some scenarios, once the message has been deleted, nobody hold the ground truth anymore. The consumer can dispute to say that, yeah, you tell me A, B, and C, I do it that way. Now I end up in a loss. And you have to compensate me. And your message brokers in the middle have no proof at all because all the data has been deleted. Right? So there's a log-based message brokers. They can save all this information. Right? You consume, fine. But I don't delete. But then in that case, how the downstream consumers know which information has been consumed. Because in the standard setup, once you acknowledge this information has been consumed by me, I delete it. Right? The next one, message go to consumer, it will be a new one. But in the log-based message brokers, if I don't delete the information, would the consumer going to see the same information again and again and again? How would I prevent the consumer keep on reading the same information again and again, because that information is always at the front of the queue? They implement something called offset. Assuming these are the message in the brokers. Simple stand up, the simple message brokers, once you read the message 5, erase them, right? Then the consumer come to 4, erase them again, right? That one straightforward, no brainers. But in the log base, since you want to save the records, because you worry there's no golden source of truth, people dispute with you, right? You keep them. But for each consumer, you keep something called offset. This is 1. This is minus, this is 0. This is -1, -2, -3, -4. This consumer keep track of that. So after you finish reading 0, position 0, you go -1, go -2, go to -3. Right? If you're currently at -3, you know you already finished reading -2, -1, and 0. You just keep on going forward. Something along the way of index. The other benefits to keeping all the data, I think a log-based system, is that it's called replay data. Because when the data flow into individual consumers, sometimes you do not know whether it's been stored correctly or not. You do not know whether there's information lost in the downstreams, because everything being transferred through network. Things happen so fast, right? Anything wrong can happen. You do want to do a replay. Replay means that you're going back to check, by consuming the data in the same way, am I going to end up in the same positions? Am I going to end up in the same shape and forms? These will help you to do this, because you keep all the past events or past records. Allow you to replay. How much information do you want to store there? Depends on you. How fast do you want this retrieval to happen? Very fast, store everything in the RAM, and you know RAM have limitations. Most of you probably are not going to have a RAM more than 32 GBs, right? I typically probably, I don't know, 16, right? The standard one. The heavy duty or the gaming books probably 64, right? Rarely you hear laptops carry 128 GBs of RAMs, right? Or if you see RAM not enough, all the spill over the data can put in the hard disk. But then you have to bear with the speed, right? The I/O, the input-output between the RAM and the hard disk is going to be a lot slower. Okay? Questions on this? This is all high-level concepts, right? Nothing built for you to give a try. But of course, I don't want to impose. I also do not know about your time commitments, right? So today, if time permits, I do want to reserve some times to hear from you. You got 9 project groups, right? Have you choose your topic? What's the progress, right? Maybe I reserve 20 to 30 minutes at the tail end of today's lectures. Each of the project groups, your CEOs, your team leaders, right? Let me hear from you. I give you enough time to prepare, huh? But if you are not ready, just raise your hand, sir. We're still discussing. That's fine, right? I'm not going to force you. But you definitely know that I think by end of the semesters, you need to submit the reports and do our presentations, right? So today is more like a checking point. And if you have some nice ideas, share here as well for your peers to hear a little bit more. So I reserve probably 20 to 30 minutes of today's times. We discuss for me to understand a bit more about your project groups. Can we put, oh, how many pages do I have? I've got 50 plus pages, but the last, I think, 10 plus pages, I think, are appendix, right? So we don't need to go through for you to read. Where am I now? I think we're here. Let's take a quick break here. And how many minutes of break do you need? Anybody want to have more than 10? How about I give you 15 minutes for you to start to think as well, right? Because later on, right, you know, when we talk about projects, you cannot keep quiet. All of you need to sort of send a reps. Minimum to say, sir, I think we're still discussing. I do want to make sure you guys benefit from the project experiences as well, right? Check with me if you want. All right, I'm going to see you guys, I think, 15 minutes later, 5 minutes later. Let's wait for a short while for all the students to return. It's also for you that to think about, I think, later on, how do you update your project status, right? I'm going to invite you, center reps, come to here. If you're comfortable, not comfortable standing here, that's fine as well, right? I'm going to deliver your mic. Yeah. With a few minutes to share where you are, what are you doing, etc. Yeah. We've got 9 project teams. Do you want to make sure you guys are doing great? Okay, let's return to the class. Project 1, do you have reps here? I mean, I'm not going to do the project updates now, right? It's after I complete today's lectures. Do you have reps here? Project 1? Project group 1? Who will be the reps? Okay, great. No, not now, don't worry, later, not now, okay? Project 2, project group 2. Got reps, okay. You already fixed who will be the CEO represent the team, right? Okay, great. Later, I'm going to invite you to be here, one after another. Project 3? Fantastic. So later, once you come to the podium, you introduce which project team, project groups you represent and your names. Then you start to talk about a topic. A few minutes will do, 4? Project 4? Project group 4? Any reps? It cannot be the entire project team, I think, missing from here. Yanru. Oh, yes, you have the reps. Are you okay? Later on, your project group 4 send the reps, talk about your project. A few minutes? Still have discussion, right? Okay. How about project 5, group 5? Reps, you have, Okay. 6? Have, Great. Great, 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 great. Later on, when you guys be here, I'll be here, right? I'll probably take some picture of you as well on the front. 7? Okay. You are the CEO, right? Okay. 8? 8, I'm not really worried. There's so many familiar names here. Okay. 9 is empty. 10. Fantastic. All right. So let's go back to lecture notes. I'll only touch about the core parts, right? So without going to every single pages, there's 60 plus pages, it's too much, right? So I make sure the core concept come across to you so that you can appreciate. And then the details, you guys start to read a bit more, right? So do a quick recap on what we discussed in the last 1 hour and 20 minutes. What is a streaming data processing? How is that different from a typical batching data processing or batch databases? Before I go further, I need to make sure the fundamental stuff, the message I get across, right? Keywords. For streaming data processing, the information being passed through is unbounded. And the message to be sent across is a series of data points / events. And all this must happen in real time or near real times. Otherwise, why I call streaming. And for streaming to happen, you need to have a few different parties. You need to have a sender. Sometimes we also call them producers. You also need to have a receivers. Sometimes we'll call them consumer. If you want to send the information directly between producer and consumer, you may end up into a few different situations. What are those situations you may encounter? Situation number 1, producer send too fast, consumer cannot digest, information get lost. It's the direct linkage, yeah? There's nothing between, there's only a linkage between producer and consumer. Scenario number 2, producer mute, sorry, not producers. Consumer mute the producer because it's too fast. Say that you cannot send the information to me anymore. Scenario number 3, they negotiate. Don't send too fast, do slowly. And people are aware of that, the limitations when you have a direct linkage between producer and consumer. It creates too much dependency, right? The example I'll give it to you is a postman send the parcel to you. You got to be at home, otherwise that transaction cannot happen. So people say, I need to introduce something to break the dependency, to decouple between producers and consumers. And the way we introduce is broker, poolings, inventory betweens, to decouple the dependency between the two entities, producer and consumer. I will also briefly explain to you how does the producers and consumer interact with the brokers. You push the message to the queue or the brokers. The downstream, the consumer will go to the brokers to read the information. Not by constantly use a while true loop keep on query, right? That's a DOS attack. Of course, I'm just using analogies, right? You be notified when there's a new message being inserted into the brokers, event-driven, right? Then the consumer will going to take their information. Once that information has been acknowledged, read already, you delete that from the brokers or message queues, inventory pooling, right? Whatever name you give it to that. That's the core things we discussed in the last 1 hour plus. Then we talk about the scenario. What if I want to maintain a golden source of truth? Just in any case, after the message has been deleted, the consumer consumed the information in the way unattended, then the unintended, Then you may dispute with the financial organizations. I want to leave a records. Then you talk about log-based brokers. You keep all those information there, right? You can keep that into the RAMs, but a RAM have a limit of space, 32 GB, 64, 128. Enterprise server-wise, I think have a bit more. Inevitably, if you want to save all the information there, you might want to push that into hard disk. If a hard disk have 20 terabytes, then it becomes a lot of information. And in that case, you may want to consider distributed systems. Why? Don't forget, this is streaming data processing. You want to have fast speed, right? If you're trying to have all the information in a single server, 20 terabytes of the data, you want to make sure the computation is super, super fast, then you have to have a faster, big CPUs. And usually that will be expensive or does not exist, right? So you may want to distribute those data into different PCs. So that if, for example, a very naive way, right? All the informations begin with letter A, stored in computer A. Begin with letter B, stored in computer B. So if I need to do a quick queries, right away I point you to computer A to retrieve this information. Let's say the downstream consumers want to retrieve all the information, want to retrieve A information. Instead, you go keep on searching with your hard disk, right? You direct that traffic to computer A because you know information over there. Would it be slightly faster? People say, hey, sir, why I got so many informations? Why I have so much information? End up is a real streaming system. How can you have 20 terabytes of data, right? Usually just a few where I have so many. Let me share with you examples. You guys know double 11s. You know in 1 second how many transactions it happens? 1,000s? 10,000s? More than that. That's the pace they're talking about. If I use a direct linkage, downstream, which is the server side, cannot process, never mind. I just reject the order. There is an opportunity cost. So all these informations, even though you may have a lot of information, come to your message brokers. All this information potentially that you might want to stop somewhere. When you have too much such information in your message broker, you may want to conditions, you may want to consider have a distributed way to store them, right? I hope that this I think ideas flow through naturally to you. Then the stuff we discussed for distributed system will start to kick in, right? Why? How do we distribute the load, and in what ways? How do we make sure the CAP theories continue to hold? I hope you guys still remember what is CAP are. Consistency availabilities. P is a given for distributed systems, right? But then for real-time system, how do you make sure I still continue to have the fast pace? Then depends on you, right? How you want to design the system. And typically this type of job, you guys don't need to worry, right? They will never ask a fresh graduate to work on this, right? They say, hey, can you help me to design a system so that it can handle 3 million transactions per second? In the same time, the information will not be lost. It can be distributed across multiple different machines. This is a data architect's job. Not a data engineer's, sorry, I shouldn't say, not an entry-level data engineer's job. You may say, hey, sir, if I really aspire to be a data architect, what should I do? I think in the later part of the lectures, I will share with you for what I know, right? From very entry level to senior level to the chief data engineers. Sometimes people say this is not data engineer, this is data architect, right? What are the things you potentially need to know? It's just unfortunately that in order for you to do that, you probably need to join a very big organization. Right? The small startup sometimes doesn't have that kind of a skill of the data asset for you to manage. Okay, come to the business part, right? why financial institutions pay so much attention to real-time data processing or streaming data infrastructures. In fact, this happens, I think, not so much in the wholesale banking space, right? This is more on the financial trading side. Retail banking side, a bit more as well. Why? In the wholesale banking, when we're dealing with the corporate type of customers, we'll negotiate a thing on certain things. It's all through relationship managers. You're not even talking about systems, right? You don't press a button, you ask the clients to quickly accept, otherwise the market condition will change. Typically, you will not be in this way. It typically is the relationship managers handshake with the client, CFO or CEO, strike the deal, negotiate the price. After that, the relationship managers will bring back the deals, ask the ops team to key all this in the systems. So typically, it's less time sensitive. Unless you talk about global markets, people want to do FX tradings. Even for that, typically, I think you don't expect the clients are right to receive the real-time information and start locking the deals. Typically, again, it's offline negotiations based on the FX exchange rate between Singapore dollars and USD. This is the one we're willing to quote to you, 1.2. Whereas the real market price, I think, is probably 1.25, etc. The bank also take a bit of risk as well, because the market condition can change. In general, you need to add in some buffers. So wholesale space, not too much real-time data processing needs. Most of the data processing has been done by batches. For example, if you are customers, when you make a cross-border data payments, they call TT, telegraph transfers, right? Do you think you're going to know the status right away, the payment whether it's successful or not? You won't. Why? Because for cross-border data transfers, you need to pass through multiple hops. From your bank to somebody else's bank, then to a third bank, then to the destinations. Through SWIFT network. Maybe adding a bit of elements here so that you guys will be able to appreciate. This also linked back to the financial world. I think how does the world financial system are interconnected with each others? You guys know SWIFT network, right? SWIFT is a network that connects most of the world banks come together. And why the banks need to join a network? When I need to send the money from bank A to bank B, can't I just simply send the money across? Why do I need to join a network? The reason is that for bank A to send money to bank B directly, they need to establish a relationship. They need to do a handshake, just like an email address. For me to send an email to you, I need to know your email address. And because now you're sending the money, right? I probably also need not just the email address. I need to check your identification numbers. Do you have enough reserve, etc., right? Before I dare to send payment to you and receive your payments. That's called KYC, know your customer. Of course, this KYC is very different from the commercial world, right? Because when you're dealing with a bank, that bank is your customer. You have to know them as well. It's a very tedious process. So most of the banks, they will never be able to know all other banks in this world. Many, many banks, easily 10,000 plus of them. There's no way you can establish relationship with 10,000 such banks. Too costly and unnecessary because majority of those banks, you're not going to do business with them. Unless you're a global bank like Citibank, right? You have a business everywhere. So you only know the one who are you dealing with very often. Singapore Bank, maybe I think the neighboring banks with the global banks like Citibank, Standard Chartered, HSBC, right? You work with them, right? And some other Malaysia banks, Indonesia banks. But what if you need to make a transfer to somebody from, let's say, South Pole? Then how? Just because of that, customers, you need to send your bankers to shake hands with the bankers from somebody from a bank from South Pole. Doesn't make sense, right? So the SWIFT network comes into the pictures. I know a global banks, let's say Citibank. Citibanks may know a bank near Finland. Maybe not Finland, right? Some other Euro bank. And the Euro bank somehow may know a bank, that bank in South Pole. Through these connections, you will be able to swift the money across. You don't know the South Pole Bank directly, you feel there's a race. But I know the global banks, right? And the global banks know the Euro banks because they trust each other. And the Euro bank, because they know the South Pole Bank, they trust each other, right? So through this network, you make sure the money flow through. So every time when the money change hand between the financial institutions, it's called the pass-through one hops. This is not real times. Far away from real times. That's why typically when you do a TT transfer, telegraphic transfers, it usually take a few days for the other side to receive the money and for you to know the status has been completed as successful. This has been accused by many industry participants to say, nowadays you still talk about a few days, then you can see the transactions. So people say, how about we use blockchains? Decentralized. We don't need so many hops in between. So come back to the SWIFT network. Besides the latencies, right, not real times, what other function does it serve? They connect all the banks together, right? Facilitate the payments, even though you don't know the banks which is far away from you, but through multiple intermediaries, the money can still flow through. There are also other, again, I'm not a banking, this is not a banking lessons, right? But I do want to continuously give you a bit of a banking knowledge, right? This is, finance, right? So SWIFT can also serve, I think, a role to make sure the international communities have the authority to control the monetary flows. For example, if a bad guy, a drug lord, has been banned in one country because I think he did drug business, right? He been caught, so he been banned. And if he want to send the monies across, obviously in that country he can't, right? So he may want to choose to move the other place and send the money to the place that he want to send. And because the SWIFT is such a wide connected network, right? This information will be circulated. The top, right? It's called do not on board list or sanction list, right? Even in the rare scenarios, right? Such information has not been relegated to the banks that the drug lord is using. When his money passing through multiple hops, and typically the hops, the nucleus in between will be those global banks, right? Citibank, HSBC, etc., right? Because in order for you to reach the destination, you can't run away from those central nodes. They are the ones who have the widest connections, link the entire ecosystem together. When this information pass through his systems, the KYC, the transaction monitoring algorithm, will kick in. Say, hey, this guy is a drug lord. You can't let him to swift in the monies, right? So they will block. So long across the whole chain, there's one or two entities serve that functions, the money will not be sent across. You are actually doing anti-money laundries, serve the entire communities a good. Of course, the SWIFT could also be used as another tool. For example, right, if country A and country B have military conflicts, and the international community decided country A is at the wrong part, so the SWIFT community can kick them out. All the transactions from that particular country will be rejected. This happens I think a few years ago. I don't want to mention, I think, which countries. Right? Two neighboring countries have some military conflicts, and one country has been kicked out from SWIFT systems. All the transactions in and out, so long as from that country, will be blocked. You can't do that. If you, as a bank, you facilitate the payments, the authority going to impose the penalty on you. Anyway, I'm not going to digress too much from this. So the needs in the banking system, in the banking financial sectors, I think on real-time information varies across. Some BU need more, some BU need less. I think this is just a recap, I think, on the stuff we discussed, right? What is the difference between the batching data processing system and streaming data processing systems? One of the key differences is whether the data is bounded or not bounded. Okay, I think this is a simple example. I'm not going to go into details. The same thing, right? If you have a direct way to send the data between producer and consumers, what are the potential drawbacks? And what the current way, how the existing technology sending the data across. This is actually not the current modern way, right? This has been there for decades. I think TCP are the one that is applying the back pressures. Means that when the downstreams, if I didn't remember wrongly, if the downstream consumer can't process the information on times, they will block the upstream, continue to send the data to them. Unix pipes is perhaps the other way around. Event streaming, that's the same. This is the three scenario. This is the two scenario we discussed, right? The third scenario listed here essentially is the message queue, right? And we also discussed, I think, the scenarios that the downstream, upstream negotiate, you slow down a little bit. It's not here, right? It's the other example I give it to you. Skip this. I think we also summarize the differences between so-called the bounded data and the unbounded data. For bounded data, I think we spend enough time to discuss, right? When we talk about the SQL databases, even for distributed data processing systems, majority of them are bounded as well. Every time when you're sending a data, you consume a data, you clearly know that you are stopped. It's not continuous comments, right? So I will not further elaborate more. Anyway, they are not the critical ones. Yeah, the the time, the windows, and the watermark. I think that the three attributes I do want to talk a little bit more. Right, just at the beginning of the lectures I talk about, right, the event times and processing times. I think are the one are pretty important. What do I mean by event times? Event time is when the data points or the event is generated or occurs. Processing time is that I think is when the information has been processed by the downstream consumers. Why is it important? I think the example I give it to you here. Event could happen in this sequence. Processing times or processing orders can be in reverse sequence. Why? Because the queue is not first come, first serve. And the network conditions can vary as well. Even first one comes, everything goes okay, when you read the first event first. And of course, the processing time will be slightly after the event times. I think this one, the join, I think is not very accurate. It should be here, right? The processing time cannot be happen before the event time. I'll change this. Not very correct, right? Second events, blue color here. Third events, black dot here. But due to the traffic conditions, it could be very likely that E3 arrived to consumer first, ahead to E2. So end up, the E3 has been processed first, followed by E2. As I say, right, I think that the E3 probably should happen after the events of E3, right? I'll revise this afterwards. People will say, what's the big deal? Why the sequence is important? I process all the tasks. Why the sequence is important? No, it depends what kind of data is inside. If this is stock-related information, no need to be stock-related information. If this is a stock price, E1 tell you the price is $10. E2 tell you this is $11. E3 tell you it's $13, right, in the right sequence. What you see if you read the things in the right orders, stock price going up sharply, right? But imagine when you read the information in different orders. 11, 13, then 12. You may give a different conclusion. The stock is very volatile. And based on that, you may make different decisions. That's why it's important, right? The order of you reading the information. Then people see that, yeah, if you're trying to derive certain logic, you do not look at the processing times. You look at the event times, because the processing time will be there's too many other factors will impact your processing time. Don't forget all this happened very, very quickly, right? This is not like a batch job. The data is being available yesterday, now you're trying to consume, right? This probably happens a few seconds ago, sometimes even less than 1 second. So, people say, you know, in order for you to preserve the correct order of the information, which is the event times, when you doing any downstream data processing, right, don't refer to the processing times. This may be confounded by many other factors like network delays. Just look at the event times. Anyway, the events data or the stream data will carry this information. And let me go back to the previous few pages. You see? When the streaming data is being created, there's a timestamp there. These could be perceived as the event time timestamp, right? When this message reach to you, the downstream consumers, you also have a system clock, right? That's your processing times. Don't rely on that in general. Event time will tell you the right orders and right sequence. I know this might be difficult to so-called to digest that because you guys never encounter an application like this, right? This is purely theories. So if you can, maybe the so-called the pseudocodes I think attached in the Canvas course materials, right? Give a try. It will take a while for you to try things out, but if you try, you will find a different word for programming, because most of you, trust me in the past, right? When you program, you never consider multiple different parties to consume the information. One sends, one consumes. And the sequence typically has been programmed by your code, right? You execute step A followed by B and C and D, right? It's already in that nature. And suddenly that you need to deal with the uncertainty. That will bring a lot of fun. Because things can come in different orders, right? Okay? I think the unbound data set, I think, are not windowing strategies. The information can come in continuous ways, right? 1 second you can have 1,000, 10,000 data points. But in the downstreams, when the consumers produce the insights, they do not necessarily produce in real time. And sometimes, ideally, they shouldn't produce in real time, because if the insights is needed, in 1 minute, how many transactions do I have? Then you need to wait for 1 minute to pass. Then you start to produce that reports. Or how fast do I get the orders? This is like open-ended questions. How fast during the peak periods? How fast when the transactions come in? Be it the banking system or e-commerce systems. There are more than one way to answer that questions. One is that I treat this as a batch job, right? Even though I think it's a message broker, a message queue systems, right? I don't need to compute every single second. I break them. by fixed time window. Every 5 seconds, I do a quick tabulations. How many orders, how many transactions comes in, and I report this. So this is from 1 to 5 to 10, 15, 20-ish, right? Every 5-second windows, I do a computations. It's called tumbling windows, fixed length. The other way to say, hey, you are reporting the insights only very 5 seconds. I want to happen slightly more faster. The other way is that I do a sliding windows. At the 5th seconds, I take all the data points received in the first 5 seconds. I do a tabulation, total counts. In these scenarios, I do not need to wait for another 5 seconds. I just wait for 1 second. From 2nd seconds to 6 seconds, I also have a 5-second window, right? I compute the total counts. These will give me updates every single second. In a 5 seconds windows. So you get insights refresh slightly faster. And the last one, I do not know what is the right length. I do not know. I just based on the activities, right? If in these seconds, things come very, very fast, then I just report to here. In the next maybe 10 seconds, nothing comes, then I just continue to wait until I meet or trigger certain threshold, right? Maybe I minimally, for me to report, you need to have 100 transactions, right? I keep on waiting. So you will have a dynamic window size based on sessions. Again, just have a feel. I think after your graduation, people will ask you, hey, what is the ideal length, etc., right? But you need to know, right? If I make things slightly tricky, right? This is under the deterministic situations, right? There's no delay, no package, no data loss. When you cut off here, all the informations happens between the 1st second and 5th seconds you already receive. Just now we'll talk about the event times and processing time, right? The example I'll give you to use. Always got delay, right? You send the information across through network, always got some delays, right? How do we know at the 5th seconds all the informations, all the transactions happens between the 1st seconds and 5th seconds are already received? How do I know? There could be network delays. Then people introduce a new concept called watermark. I can't guarantee at the 5th seconds all the transactions happen between 1 and 5. Well, I will definitely receive them. No way, right? But I know, based on my assessment on network conditions, based on the past empirical evidence, right, that even there's a delay, but the delay will never be more than 1 second. So by the 6 seconds, I can guarantee that all the transactions happen between the 1st and 5th seconds. I guarantee I receive all the data. So watermark serve for that purpose. I just put it here first, without going to deeper. People will say, hey, then sir, by setting different watermark, what does it mean? How am I going to use the watermark to process the information, right? a lot of times you don't need to be the one doing all these configurations, right? So there will be system default. Only we start to see, hey, how come I assume things happen, right? Later on, suddenly, there are more messages, I think, in the queue start to pop up. My number I computed in real times. Later on, when I play back, I notice the numbers, the stats I get here is very different from the one I get later on when I try to play back the data in the log-based database systems. That is because a good portion of the data arrive later than the perfect timings. When you do the computation based on perfect timings, you didn't consider all those data points arrive late. Watermark essentially tell you how late could it be. So you may want to adjust the computation. Do I need to wait for a little while? Or if it's so late, do I want to make sure that I have a proper system configuration so that I don't need to be so late? Again, I don't want to go into further details, right? Introduce too many concepts already. State management. I don't know whether I should. I think maybe I trying to explain in a very simple way, right? The example I give it to you, when you're trying to compute the total counts in the last 5 seconds, right, or last 5 milliseconds, it's not just based on the most recent transactions. It's based on the transaction in the time window, right? There's a dependency. The other one, which you can potentially use, especially in the banking systems, right? You want to check whether certain transactions come from certain countries. For example, Russia. By no means disrespect the Russians. If Russia continues to be sanctioned by the international financial communities, then if you detect their transactions, you're going to block them. You don't need to depend what transaction or what message do I see prior to that. No need. Just based on that, right away you can make a decisions. So these were tiebacks in the downstreams, in the consumer side. Once you receive the information, you also need to process them. And the process needs to happen very, very fast. And you can't say that I want to. Okay, treat it as a noise. Yeah, I want to spend 5 minutes to process the downstream information. I mean, you have the flexibility, but a lot of times the fact you need the real-time information is because you want to make the decision fast. And let me give examples. In the fraud detection systems or in the fraud detection scenarios, if your bank systems send you a message, customers trying to move out 20 million Singapore dollars from his account, and that's all the money he have, and in your fraud detection downstream, the consumer side, the consumer in this case I think can be your fraud detection, real-time fraud detection algorithm, right? You need to make a quick decisions. Is this a fraud or not? If it's a fraud, you got to stop them, and you probably only have a few seconds. Because if it take 5 minutes, if it take 5 hours, the money may be swept out ready. And how do you use limited information? In this case, really you have limited information. You cannot say, I want to pull all other information, I want to run a machine learning model. Too bad. In order for you to do that, it's going to take too much time. You have to, based on limited information, make a quick assessment. And that also explains why some real-time detection algorithms may not be as effective as the offline detection algorithms. Because real-time algorithms have limitations. It's not the algorithm is not smart. It's that the algorithm need to return back the information in a very fast manner. Sometimes it doesn't have the time to look for alternative data and spend enough time to do the computations. Whereas the offline, you can spend enough time to get all this data, build the features, churn out some sort of a propensity scores, and based on that, you make a decisions. Okay? I think that's pretty much all the details about so-called the message queue systems, right? The rest, I think, are trying to talk a little bit high levels. Lambda architectures. I mean, I guess you guys just need to know the name, huh? Don't need to go into details. Yeah, there's a little bit on the architecture already. I begin with the Kappa architectures. Kappa architecture is nothing about typical message queue systems, and this message queue systems serve for streaming data processing. You got a brokers. This is a broker. The upstream data generation, I think, is not here. Broker taking these informations in real time or near real times. You got the downstreams, the consumer, with real-time processing engines. I mean, the name is called Flink. What does Flink do? You guys can try to search a bit more. It's a real-time processing engines, right? Can allow you to implement certain logics to detect the patterns. Kafka, I think, is just Apache Kafka. I think is just message brokers and message queue systems, right? It have limited processing capability. What do I mean by processing capability? Does not mean that you cannot process the data, right? You have to condense the data. Processing means that you get the data with the capability to transform them, find the patterns, etc. Right? You have limitations on that. Flink can do that fairly better, right? Then after you process this, you may want to trigger some downstream actions. In this case, the downstream actions is probably pumping the insights into some sort of a DBs, or you can actually pump this into a dashboard, or this can trigger another actions. For example, log the customer's account. If I detect this is a fraud, right away, without asking, log first. And then you pass this insights to the bankers, which typically may take a while, right, a few hours. The banker will pick up a call, assuming it's the fraud detection cases, right, to call them. So these are all the downstream consumer parts. Kappa architecture, focus on streamings, real time, near real times. But in another scenarios, you may have a lot of historical data, right? Assuming it's a log-based system, right? You may have a lot of historical data. The downstream consumers may also want to consume the historical informations. Well, we all know, right? In the Yahoo Finance cases, when you want to consume the historical informations, does it need to be real times? May not always be. And you have very mature, established way for you to consume that. So Lambda, I think, architectures it's a hybrid architectures. It allows both real-time, near real-time data processing, as well as the batch data processing, like the traditional databases, right? But the drawback of doing that, you need to keep two different systems. Maintainability, I think, is not straightforward. Again, high-level architectures without going into details. So you just need to know Lambda cover two different approach, batch and streamings, whereas Kappa only streamings. For those of you who are interested to dig out a bit more, go online. There are a few, I think, good books, I think, may explain a bit more on this, right? Once you go there, you will know, right? These are the popular books on that. Choosing the right architectures, I think you guys read through, right? Message broker deep dive, Apache Kafka. Again, this is the brokers. It only have limited streaming processing capabilities, right? If you want to bring in the streaming capability, like implement a fraud detection algorithms, right? You may consider other tool like a Flink. This is the house, This is the house. So in the longer terms, people say, why, let me go to here, right? Why do you need to have so many different components, right? The source needless to mention, this is the producer, right? Why do you need to have a brokers or the inventory to house the information? Then you have a processing engine like a Flink to process, transform, or detect the patterns. Then later on, you have another databases or maybe a dashboard to include the insights. can't you have all the three things combined together as a tool? Of course. Now people already moved to that. So that's easier for you to use, right? All in one. I think we covered this already. This is, I think, let me delete this page. I think it's unintended. I hide that, but somehow when I convert into PDF, it still appears. I think this one just now already covered. The differences between the event times and the processing time and how critical it is, right? One more thing. It's a keywords I think I want you guys to know. CEP. I don't think I put in the notes. Complex events processing. The example I gave it to you just now, that if you detect whether a transaction comes from a sanctioned countries, this is it's not considered as a complex event. Just need to check, right? And the other scenario, the fraud detection, I give it to you, right? If you want to add in a very complex patterns inside, that's called complex events processing. Again, you guys Google what is the state of us, how people are doing that, right? Your algorithm obviously cannot be too sophisticated because it does not have enough time to compute and come back with the insights. Sometimes the downstream consumer need to have a fast turnaround times. But it doesn't also mean that so long you become a downstream consumer in the streaming data processing end to end, you need to come back with always with a few seconds. That's not necessary. The way you consume the information means that when the information or the events has been created, you'll be notified very, very fast. You go there, can retrieve the information very, very fast, right? But it does not always mean in the downstreams, you need to always take very short period of time to produce a quick insights, not necessarily. Come back to this chart. From here to here, it's fast. From here, broker to process is fast. But how long would the process takes or the data processing engine takes is up to your business needs. And typically, right, the facts, because people are using this real time, right, usually there will be some sort of expectation have a faster turnaround times. But you can use the architecture for other means. For example, right, I just want to spend 1 hour, 2 hours on this process. Nothing wrong with that, right? Then you use this architectures to send the information fast, but process the information, not say slower, more cautiously. It's fine as well. Then people may generally will say, right, then why do you need to use a real-time assistant? Can't you use a batch, send the information across every 10 minutes, since you can afford to have 1-2 hours in the downstream, right? But, it depends. All right, I think this is another example, all right? I think how do you use different window functions that they can compute the insights. Again, it's the downstream data processing. That's why I can see it's a Flink, right? I think we'll also give you a few examples. I think how to compute, how to deal with the stock-related information in different time windows. Again, I think I will not, in the interest of 9:16 already. So in the interest of time, I'm not trying to go into details. You guys can read through this a little bit more. But the key thing I think highlights, right? You guys clearly know what's the difference between the streaming systems and the batch systems, and what are the key characteristics that people have key characteristics of the streaming system, and what people have done to decouple the dependency between the producers and the consumers, right? And what is the potential drawback of the conventional message brokers, right? Information will be deleted, right? So people also propose the log-based message brokers. And some of the key so-called message brokers like Kafka's, right? And the key message so-called or data processing engines will be Flink, right? You have more than one. I think, in fact, in the example I give it to you, in the appendix, we also bring in the rapid, message queues, right? Kafka, I think, is a log-based, means that I think there will be information stored even after you consume that. So give a try, I think, if you have the time, so that you really have a feel, right? How how does the systems, how does the so-called non-conventional batching data processing systems work, right? Get a feel. Any questions on this? If not, maybe I will switch to a different mode, right? Project mode. Project team 1, I think, are you ready? Yes, come here. Just want to make sure this one working.
Okay, so our group will like make to like ingest like news, micro news sentiment, like to make a pipeline for like risk indicators to help portfolio managers.
Okay, so to have the news pipelines.
Yes, we will like ingest like news from mainly from API.
Okay.
And then the progress is now we finished the extraction, the ingestion we finished. We're now like still in the progress of the transformations.
Okay, how you are prepared to store those informations? In what way?
For now, we plan to like store it into like the SQL database.
SQL databases. Why do you choose to use SQL databases?
Because I think using like SQL would be like more efficient, because like if we use like Parquet, it would be like too hard to read, and if we use only like a data frame, it's also like not compatible with what we want to use.
Any particular scheme does the team consider to use? Schema, data schema. You can have more than one people come to here. Really? Yeah. So Tanya will come, right? Yeah. And the rest of the team listen, these are the competitors, okay?
So some of the other things so largely at this moment it's star schema.
Okay.
To be honest, because ideally we would have the same kind of news reported on the same date. And the essential idea here is for portfolio managers or for anyone who's in the business, news is a huge driver in terms of decision making. So the idea is really to quantify the kind of signals we get from the news.
Okay.
Yeah, so that's really the problem that we're trying to solve here.
Okay.
In terms of data engineering. So Talia also, she mentioned SQL database, so we plan on using like a hybrid model.
Okay.
So we have some on our local where we run some of this, but we also, in order to allow for parallel processing between different computers, we've hosted some of our data on a cloud-based system as well. Yeah.
So it sounds like a distributed databases, right?
Correct, yeah.
How do you do the sync?
How do I do
How
that?
do you do the sync?
You can do the sync in two ways. So we do have automated jobs where we pull from different data sources. So it can be a cron job, which does like a retrieval of data from different APIs. That's the first. And a schedule job like that also pushes to our shared data source on scheduled intervals.
Okay.
Yeah.
So the downstream is going to be our visualization dashboard.
Correct. Yes.
Where do you put the information? From the cloud data sources or from the local ones? And how do you choose to? Which source do you use?
So currently at the moment, since as Talib pointed out, we are in the data ingestion phase, we're choosing to put our curated data storage on the cloud.
Okay.
Also, because part of the reason is also because as we've learned, it's a pay as you go.
Okay.
So it's better to put transform data there and be able to just work with raw storage on your local.
Okay.
Yeah.
That's a very interesting way, right? You store the raw data at the local, then curated, supposed to be a smaller data set on cloud, right?
Yeah.
Typically, it's the other way around, because it's safer. But I understand where you're coming from, right?
It's because we, as students, we have to be cautious of the pay-as-you-go.
Which, are you using GCP?
No. For now, we started with Azure, but we can look at other sources as well.
It doesn't have to be. I think usually this service, cloud service provider give us $200 to $300 free credits, right? Maybe your GCP's one already done, yeah? Okay. Anyway, talk about cloud, and thank you for both of you, right? Any question from you guys? This is not actual presentation, but actual presentation format will not be very different from this. I hope you guys understand, I think, what is the problem statements they're trying to solve, right? By the way, give you guys the updates. I'm trying to do a follow-up, I think, a few cloud service provider. They are very keen to come over to give a talk. to share how to use the cloud, especially on the data engineering part. Now I have a problem to say, which one do we allow them to come? Yeah. I can't allow 4 of them, right? Otherwise, we don't need to teach already, just listen to them, right? So I guess you guys are more familiar with like Azure and GCP, right? So let's go something a little bit more exotic. The familiar one, you guys anyway you get a touch, right? Yeah, I'll say lah, I'll say lah. But not to the extent only there's one user in, 1 or 2 users I think in this world, right? Not to that niche lah. I'm trying to choose the less popular but less common. Okay? All right, let's go. Project group 2. Where's the CEO? And feel free to book my consultation hours if you need me, right? Don't get it last minute. I can guarantee you, when 10 project team come to me to book my time, 9 will be rejected because I only have that 1 hour, right? Yeah, go ahead, please.
Yeah, actually,
you can use this. You can switch on. Yeah. Yes.
Actually, recently we saw a paper called the multi-agent system for deposed financial reasoning and forecasting. In other class and project we have we are trying to
in other class.
Yeah, actually it's a big program. So I think we will in this class we will in other class we just reproduced and reproducing and extending this this paper. So it's a multi-agent project. So in this we are trying to collecting some data in this class to calculation it and train this project again. Yeah, train this model again, the agent.
So you're trying to work a project for the other class, and this class is trying to get the data down and fit to a project used for another class.
Actually, I think this is data engineering and data collection and data cleaning. It's a very important work. But not about the other class. It's just prepare the data for this.
Okay,
project.
so what is the problem statement? I understand you need to get some data. In what domains, what context you are trying to get, or what type of data I think are you guys trying to work on? Financial data, transaction data, news data, or other type of data?
Most of this is financial data.
So what problem are you trying to solve for the entire project? This is the problem statements, right? We're trying to understand, sir.
Yeah, actually, this problem maybe is solving for 3 weaknesses. Because these end-to-end models often have three weaknesses for financial. The short-term stock selection is difficult because market signals are noisy. Non-stationary and spread cross-structured data and unstructured data. So the end-to-end models often have 3 weaknesses. The
Sorry to pause you here. Huh? You start to talk about models already, right?
Oh yeah. Okay.
Yeah, I think first of all, what exactly is the problem you're trying to solve, right? You can combine the data and model together. I need to understand their problem statements. Then you come to the data engineering part. The model part you can describe a little bit because it's linked to the problem statement, right?
Yeah.
I still fail to understand what the problem is trying to solve.
We think the data that they used in this paper is not very new, and it has some structured problem. So we try to fix it and make a new, better data set.
I see. No issue. I think I understand what you're trying to do, right? You're trying to bring a new data set to enhance certain models, right? Yeah. But the detailed context in what way, under what, I'm still less clear. Maybe, it's okay, right? This is the first time you guys trying to bring the ideas. Go back to discuss with the team a bit more. I'm looking for something, for example, right? I'm trying to dealing with the stock data, right? Cover different stock information. I'm going to use the stock to come with the new trading algorithms to predict the stock price 20% better than the state of arts, right? That's the problem statements I make.
Oh,
Yeah,
okay.
yeah, yeah. A little bit more specific. Okay, no problem. I think it's a good try. Maybe
Okay.
you can go back to discuss with the team, right?
Okay.
How to shape the problem statements in a more specific and clear manner, sir.
Okay.
But thank you for coming to here.
Yes, thank
Okay.
you so much. Yeah, maybe I'll try to.
Yeah, and feel free to book my time if you need my input, so that you don't need to go into the final presentation. If it doesn't fit, then you guys are running a race, lah. Huh? Yeah. Okay. Project 3.
We haven't confirmed what.
Come to use the below. Yeah, this
Yeah.
is
We haven't confirmed what we want to do. We just implore something. This week and last week we explored about the flight data. As we all know, the flight company show their data such as RPK every season. But if we want to get alpha from the financial market, we need more. We need more higher frequency data, and thanks to the hyperfeed, we can get we can get the information in time, such as the ticket price and the type of the plane and the and the number of people by the tickets, the begin and the end, and whether this plane arrive at time, and more information.
This is just one of the ideas, right? The air ticket price is one of the ideas you guys want to explore.
We want to get the we want to get the flight data from the hyperfeed to calculate the flight company's flight company's.
It's okay. It's okay. Okay. I think no problem. I think go back. I mean, the team is still trying to explore. I think multiple different ideas. Not finalize the topic yet, right?
Yeah.
Yeah. I think you no problem. You guys are probably need to speed up a little bit, because I think this is week 7 or week 8, right? Yeah. You guys don't have too much time ready, right? Go speed. Yeah, the CEO of the team need to speed up with the teams to make sure you finalize the topic. Then also, when you choose the topic, you make sure that you have enough data points, right? It's not just a simple Excel files. You put them into data marts, database.
The topic is we want to construct the factors about the flight company.
Factors.
Yeah.
What is factors?
Such as do you know RPK?
Okay, no problem. I think you know if you want, you can book my time afterwards, right? We can discuss in details, right? That is for me to understand where is the progress of the teams. Okay, project number 3, Yeah. Okay, thank you very much. Yeah. Project number 4. Yes.
Hello.
Hello, Xian from Project 4 here. So our project name is a sentiment analysis for single name stocks.
Segment analysis.
Yeah, for single name stocks.
Okay.
And then the objective is to create an end-to-end data platform, end-to-end data processing and analytical pipeline. And the goal is mainly to help a single stock trader to provide trading ideas based on the ongoing social media comments.
Okay.
The backgrounds, so like, reason why I choose this is because the team is interested in the relationship between sentiment and stock price. And also, like we believe, from data perspective, there's various data there's various data type because there's numerical data price plus there's unstructured text that we want to take from social media. For the steps, there's like the common steps like raw data collection, storage, cleaning, and transformation. Definitely there will be engineering since there's text included. And then there will be a curated data storage as well, data analytics and EDA and the modeling plus the backtesting.
Okay.
That would be the full steps. For tech stack and infra is not finalized yet. The primary idea is on-prem. But I think we prefer data lake to be the storage, but we haven't decided the analytical.
Data lake as a storage.
Yeah.
How much data do you have?
I don't know. Depends. I think for now we are still aiming to take the hourly data for number of stocks, but we'll see like the capacity of the machine.
Okay. Typically, I think when you do data lake, that usually means enterprise.
Okay.
That typically means that you think about the data of size of P. It doesn't mean that you can't do it, right? Even for problems you have like 1 terabyte or 500 GB, doesn't mean you can't use the data lake architectures, right? You store all the raw data in one tiers, right? And then you pick up the one, you transform them, aggregate them, curate them, and put them in the second tiers. This will become your data mart or data warehouse, right? Then you use that, assuming you assign certain data schemas, use that to serve your dashboards. There will be a nice data lake architecture. It's just that maybe for a small problem, you don't need to use that, right? But I think for a project, that is acceptable as well. It's for you to demonstrate, I think, a concept, right?
Yeah, we haven't decided yet, to be honest. I think even cloud can be a method, but we don't know the pricing yet. For cloud, I think using Azure, like with the Azure blob storage and Databricks for analytics.
Yeah, if you don't have a huge amount of data, for example, just a few GB or few 10 GB, won't be very expensive. Right? You won't store there for forever, right? After the project presentations, you can put it down.
Okay.
Yeah. You want data storage space. Go online. I think typically it costs you, I think, 0.0 something per dollars per hours.
Okay.
Yeah, it won't that expensive.
Yep. So for scope, I think we have selected some single name stock based on volume and the frequency is traded. Also, like based on like the trending, like we are selecting the names based on like the trending ones in social media for most data points.
Okay.
Yeah, and then for now it's still past several years hourly data, depends on the capacity, and then we're also thinking about the real-time one. So we'll take it from the Yahoo Finance, but I thought for level there's like a 15 minutes lag, but I think we should still be able to use that for analytics.
Yeah.
I think that's all.
All right, thank you. That's similar to your Project One's ideas. Your season sentiments, right? It depends, I think, where do you take your data and how do you store those informations, right? It's good. I think we have similar projects. They're going to do a bit of benchmark. Thank you. Group 4. Group 5. Later on, when you watch the recording, your face will appear here, right? Yeah.
Okay, this is Group 5, and we are building a data engineering pipeline for multi-factor analysis in the Hong Kong stock market.
All stock related,
Yeah.
Okay.
And the data in Hong Kong stock market is often fragmented with inconsistent quality and update frequencies. So we aim to design an automated, standardized pipeline that ingests about 5 years of market data.
Okay.
And we handle mainly 5 parts: data cleaning, pre-processing, and feature engineering for selected factors and storage. And finally,
May I pause you for a while?
Okay.
Are you prepared to do a downstream machine learning model? Because when you start to mention about feature engineering, it seems you're prepared to do a model, right? Downstreams. Of course, I'm not saying you cannot. You definitely can. This is the data consumption part, right? Yeah, please.
And finally, we will create a simple backtesting module to test the usability of our data sets.
Okay.
By the way, our focus is on data architecture, automation, and robot.
Of course. Of
Yeah,
course.
yes.
Of course. Of course.
That's all.
How big is the data set? If you talk about Hong Kong stock exchange markets for 5 years,
Yeah.
there could be tons of different data. Where do you get those?
We can use an API.
Call.
Yeah, or we have the Yahoo Finance or Wind, like the data
Okay.
platform. Yeah.
I see.
because-
So you're going to use those API to download all this data, right?
Yeah.
They need to think a proper way to store this information elegantly, right? You can bring in the concept like 3NF, right? Different data schema. Now, up to you, right? These are the things I can help you guys to think, right? And when you do the 3NF or different schema, you need to understand and try it as well. Why, for example, this schema serve nicely for your purpose compared to a normalized databases, right? When you start to code in different way, right away you can tell the differences compared to tell you in the lectures to say, this is better, that one is better. Trying this at a bigger scale. 5 years Hong Kong data, stock exchange data will be voluminous. It won't be like 1 megabyte, 2 megabyte. It will not even be 100 megabyte. It will be a huge numbers.
We may consider the year of chosen. So you mean that it's too big or like?
No, I'm not saying too big. It's a good amount of data, right? Yeah. It's big, then all the data engineering stuff I think we learn in this class will start to kick in, right? If it's too small, one way or another will still work for you. When it's big, then organize the information in one way compared to the other way. You will see a big difference in the downstream applications or processings.
Yeah.
All right? Okay, thank you for preparing this. So project number 6.
So, hi everyone. So our project, we are focusing on polymarket. So
What polymarket?
Polymarket. Yeah.
What's polymarket?
Oh, you don't know poly. So how many of you have ever betting on the polymarket? You do the same? Yeah. Oh, too bad. Okay, so I will talk a little bit more about this background. So
Okay.
the polymarket actually is illegal in Singapore, but it's an illegal gambling platform. You can bet even almost everything. For example, will the Iran change their president today? So there will be a contract on the platform, so you can bet. Why we choose this topic? Our core idea is very simple. The poly market is much better market information platform, we think, than the social platform like Twitter, because for those so-called KOL post their idea on the Twitter with no cost, but on the poly market, you have to use real money to bet on your idea. So many people with insider information will bet on the platform with a large or huge money on their ideas. So we think you can get some insider information on the platform. So the whole project is to test whether our thought is true. So what we will do is to select some what we call standard contract on the poly market, like crypto. So in the poly market, there are some contract about crypto prediction, like after 5 minutes, will the BTC going up or down? So that's quite a good signal to reflect whether the true crypto market will go up or down. So we will processing a lead and lag analysis to answer this question. So we will collect, we will choose some standard contract to collect all the order string and compare it to the Binance order string, so we can discover some difference from this true string, and then test whether the poly market will go first, and then the real market will follow it. So that's the whole idea.
Okay, I roughly understand what you're trying to do, right? How big the data volumes are, or this is just a simple API
It
call?
might be really big.
Huge,
Depends on what window you choose.
Okay, so you want to organize the information in a certain way,
Yeah.
allow you efficiently compare against a few different sources, right?
Yeah, but fortunately, the data structure are very clear. So they are, and it's really easy to access.
I see.
They got their own API, so you can access to them everywhere, every time.
Okay,
Yeah.
then I think you probably want to choose some ideas, right? When you do their comparisons, understand the data structure itself is clear and clean, but when you do comparisons, if you want to bring speed into considerations, right? How do you make sure that when the comparison happens, it's fast enough, right? If the data size, I think, for example, is a few terabytes, do you want to store them distributedly so that you can finish the comparison in 0.1 seconds? I mean, no, this is just a random idea, so it doesn't mean you guys have to do that.
We will just test this idea,
Yes,
so
yes.
we will just have to look back to
Of
the
course,
history.
of course, yeah. Okay, yeah. I can share one idea, I think, during my days doing the quantitative stock tradings, right?
Yeah.
I purchased, I think, the transaction data at the deal levels. Every single deals, right? It's huge amount of data, right? We're trying to derive, say, after per deal level data, yet if I need to derive hourly data, right? For that hour, what is the high and low price? How many transactions been done? I'll be thinking it's going to be very, very fast. What I didn't know that it take easily a few days that for me to finish the competition just for one stock. In order for me to process the entire stock exchange, I have to hire somebody else to do it for me on part-time basis, right? But if imagine I need to make a decision based on hourly data, right? The speed starts to kick in. I know it doesn't apply to your site because I'm not very familiar with the poly markets, the data, right? But if there's elements like this, the stuff we learn in this class will start to kick in. Okay, but thank you for sharing. Something new. Later on, once I reach home, I will search a bit more about the poly market. Yeah, to understand a bit more, to appreciate your projects. So project groups number 7.
So actually, we like the topic that group number 6 has ever done is on polymarket, right? Because we think it's very interesting, and but we have to mention that polymarket is banned in Singapore, so because it's kind of like gambling.
I understand.
Yeah. And our team will not use the crypto data because, for example, if you want to predict whether the BTC will go up or down in next day, it will be very hard. If you want to predict in 5 minutes, I think it's just the white noise, you know. So we want to focus on more on another field of the poly market, which is the stock price. And recent months, there has been some market about the, for example, the Nasdaq and S&P 500, and it can predict whether the other day it will go up and down. And we can see from the market itself that, for example, the Nasdaq, when the oil price goes down, and today's Nasdaq will go take a lot of pressure, right? So we can use the volatility because at the beginning, the polymarket price will be at about 50% for up or down. And then it would go through some volatility, and we can use the volatility to predict the fear index of the market, of the everyone who cares about the stock price, right? And I think another reason why we choose Polymarket is the data. The API is very usable, and we can get it for free. And I think the data of the Polymarket is stored in JSON. So we firstly need to transform it. And even though the Polymarket company has already transformed some data, it's very messy because there are a lot of information that we do not need for our specific purpose. So I think we firstly need to select the specific data and store them into like the DuckDB or use some very convenient libraries like Python, Polars, or and then we can make a dashboard of today's emotion on the market, like the fear index, and that's how we solve the problem.
Okay. Maybe I think later on, I think you can discuss with the team how to emphasize the data engineering part, right? I managed to understand a bit on the project motivations and where do you put the informations, but I've not get a good understanding how big is the data sets, how complex, how sophisticated the data set you already mentioned, quite clean, come in JSONs, right? But the volume of the data, and how does the data is going to help you to make that decision from the data engineering angles. Maybe due to the time limitation, you will not be able to articulate, right?
Yeah.
Maybe you spend a bit more time work out with the teams. Yeah. So the next time when we have the updates, I hope you guys also can, and all the project groups can spend more efforts to emphasize, right? This is the data volume, this is the data frequencies, how do I organize the information, in what way, how does it impact my final project outcomes, right? But okay, thank you, this is a very good try.
Thank you.
Yeah, all right, project groups number 8.
This. So I think for our group, we are going to do something that is related to crypto. So the reason why we are tackling the crypto market is for 2 reasons. Firstly, crypto is actually a very new thing, and even the API itself very new. So this means that in between exchanges, like for instance, we're talking about Binance or KFK, even their API is not really very complete. So we do see a lot of like incomplete data and like a lot of data transformation that we can actually do to backfill this data. That is one. And secondly, the availability of this data is because that it's very decentralized. So we are able to obtain this data freely. And the second part of our project is actually to do with like the web scraping of information. So why we are doing 2 parts, API is because we wanted to tackle missing data and incomplete data. But as for the web scraping part, we are trying to tackle retail sentiment. So we are going to like web scrape social media sites, for instance, or even go to exchanges websites where the information is not available on their API, but it's usable information that we can actually use. So that's the 2 parts of our project. How we are going to store the data is we actually are using Google Cloud. So we have about $300 credit, and our data size is about like probably up to like 1 to 2 terabytes. But given the length of the project, it will be sufficient to store the data. Right now, we do have like an approach of using like the extract, load, and transform method.
ETL, ELT. ELT.
Yeah. So we are going to have 2 buckets within our cloud storage. There's going to be the raw data set, and then once we transform all the data, we'll store it in a separate bucket for the curated data storage. We are planning to use the Snowflake schema right now because it's like a normalized like format. And then subsequently, the end product that we are really trying to tackle is to come up with like a visualization and analytical dashboard. So our whole pain point here is that retail users, right, it's very hard for them to gather like different data, especially when it's incomplete. So the purpose of us is to consolidate all this data into one, make it automated, and then eventually give back the user some kind of like platform where they can easily use to keep out all this information.
In fact, if such product is not available in the market, you don't even need to decommission your cloud subscriptions. make it available to other people. There might be people who are willing to pay. But you're using real data from OKX and other crypto exchange, right? Yeah. This could be a useful one.
Yeah.
Thank you, Marcus, for sharing these details. Yeah. Last one, but not the least one, project number 10. Project group number 10.
Okay, guys. We are group 10, and our project aims to build an intelligent investment research and analysis system based on our data. Okay, this one. Okay. Yes, such a system that integrates financial data and the large language models. And we plan to obtain this kind of financial market data by calling the APIs or and downloading data sets. And this collected data will then be cleaned and processed before being stored in a cloud database for management. And I think depending on the structure of the data, we may use different database approaches. For example, structured financial data such stock prices and the financial indicators can be stored in an SQL database, while the textured data such as financial news or some companies' disclosures can be stored using a database that supports text retrieval. But if we can get enough textual data, because getting some news is very difficult for us. And based on the data infrastructure, we plan to use an RAG framework together with a language model to retrieve relevant financial information and generate basic investment research summaries and insights.
I understand the RAG part. So you're trying to make the information available to feed this to a large language model, right?
Yeah.
To produce some insights. How big is the information? Volume-wise? GB? TB?
We haven't seen
I see.
about this question,
I see.
But I think smaller is better. Yeah.
Smaller is better.
Yes.
But then how do you organize this information? If it's too small, then essentially the focus will not so much on data engineering, right? It's probably the downstreams of large language model.
Yes.
Then you guys, the team maybe want to shift the focus a bit more, right?
Yeah.
Because the grading criteria evaluation will focus more, not on the downstream analytics. That one, you need to be there, otherwise you don't have a complete case. It's more of the upstreams. How do you store the information, transform the information, right? The data engineering part. If that part has been overlooked, then the project you may want to fine tune a little bit on the directions to pull back more on the data engineering, not so much on the large language model. I'm not saying this is not useful. If a data science class, then obviously, right? You guys okay, right? But for data engineering course, you do want to put higher weightage on the data part, not the analytics part. Okay, but thank you for sharing this in a very clear way. Yeah. Let me give a quick comment, then we dismiss today's class. After hearing the progress updates for 9 project groups, frankly speaking, right, there are project teams has been very much advanced in terms of project progress. They articulate very clear on the problem statements what they want to do, and there's a clear focus on data engineering. And some of the project team even considers, right, how are you going to organize the information? They mention about schemas. They talk about ELT or ETL. They talk about downstream the consumptions, right? They also roughly know. I mean, you guys know right away, right? I'm not liars with any. They tell how big is the project. They tell how big is the data science, and how much does it cost, etc. Right? This is the one probably make very steady progress. There are also project teams I think probably also need to speed up a little bit more by figuring out what are the problem statements you're trying to pursue. That's the basic, right? Even before you talk about data science, if you don't clear, not very sure what is the problem statements, the pain points you're trying to address in your projects, you can very easily get distractors along the way, given you don't have too much time, right? Point number 2, the focus are very much on data engineering, right? So don't get distracted. The most trendy in things, right, in the market, it says generative AI, agentic AI. I'm not saying that's not important, right? You can build that as the part of data consumption part, but you have to make sure you have sufficient enough coverage on the data engineering part, right? How do you organize the information? How do you make the information flow through? These are important as well. In the beginning of the class, we'll talk about 6 different steps, right? If you try all the way go to the data consumption part, ignore the rest, then you miss the forest for a tree, right, in this class. And the last one is the presentations, right? Make sure, I mean, of course, I caught you, I think, off the guard, right? I didn't mention you guys are going to be here, right? But in the actual day of the presentation, make sure you're very well prepared. And by structure your thoughts, right? How do you structure your thoughts? Put up the problem statement very clearly. 2, know what are the grading criteria. Well, I think I tell you guys probably, I don't know, 4th time or 5th time this time around, right? So when you present the information, you align the talking points across these key areas. Because you're not going to give 1 hour, 2 hours. It will be only 15 minutes or 20 minutes each for each of the project teams. You don't have too many chances to hit on the hot buttons, right? And where are the hot buttons? That's the grading criteria, the stuff we discussed in the last 7-8 weeks times. Okay, now, each of the team have about 10 people. You have enough bandwidth, even you start from now. And also, project carry a heavy weightage. But look at the quiz 1 result, some of the students here, 12 points, slightly less than 50%. Assuming you have the project continue to do it that way, you may want to see me next year. I don't want the students to feel that's the reason I spend extra time to make sure I check on the progress. Surprised because I think it's only very rare a few teams come to me ask for inputs. The rest of the team, or either you are very confident or you want to take the bet. And if you take the bet, like flip the coins, 50% of time you will be successful. The other 50% is the outcomes you do not want to bear with. That means fail the class. All of you want to graduate in times, or on times. Don't take the bet, right? Especially when I offer you the opportunity. Doesn't mean that you want to take all my time during the weekends. No, that will not happen. Spend your time wisely. Check in advance. If you know you're going to take exams with somebody else, right? If you know you're going to take an interview with somebody else, ask their inputs earlier. You don't need to wait for the last minutes, face the judgment days. Too late. This is the advice, I think, from somebody who have years working experiences. Always try to do sense checking earlier before you pass the outcomes or submit the reports. That you only have 1 chance. Now you have many chances. Sir, what do you think about the ideas? Sir, what other thing do I need to add in? If you care about the result, right? Now I'm telling you, some of the students, especially those of you, unfortunately, due to various reasons, doesn't score very well in quiz. If you continue not score very well in the projects, the outcomes are not very ideal for you. For me, it doesn't make a huge difference, even though that I don't want the student to feel. But for you guys, trying to speed up a bit more. This week, I will try to publish the quiz result. I really don't know who are the ones because it's all matriculation numbers. I can't see the names. I'll try to upload that so you guys can take a look, adjust the pace of the study. For projects, you have 10 people, really trying to speed up a bit more. Right? You have some time, but not too much time. All right, I think I will see you guys next week. Yep, thank you.